Hello, everybody. Welcome to Cloud Cover Show. This is Haishi, and today I'm joined by Brian and also Josh Caplan. Right? Did I say it right?
Yeah, yes.
Well, we are going to talk about Azure Analysis Services. But before we go, I have a little announcement. This will be my last appearance on Cloud Cover Show as a host. I'm sure I will come back to visit. So please show your continuous support to this wonderful show. And in case you haven't noticed, in the past few years, this show is totally unscripted. So we just go look at the content as what you would do, and we ask questions as we see it. So without further ado, let's just turn to Josh and talk about analysis services.
Great. So I'm one of the PMs on Azure Analysis Services. And how much do you guys know about analysis services in general? Product has existed for a long time before Azure.
Well, this will show my age. I was working on those OLAP AP systems like 15 years ago, doing the multi-dimensional database, Hyperion, Oracle Express, those things.
Yeah, so you remember then.
Yeah, I remember a little bit. Yeah.
So analysis services is always shipped with SQL Server. It's been called SQL Server Analysis Services. And as you mentioned, it started out with multi-dimensional, we called cubes and OLAP. A few years back, we introduced our new models called tabular models, and they're more tables and relationships. And what we've done recently, we've taken the same product out that we ship with SQL Server, and we've moved it to Azure. Now it's a fully managed service in Azure, so the same stuff you could do on-prem with tabular, you can now do in Azure, minus all the managing of the servers, and you get all the good platform as a service stuff you'd get with other services.
Okay.
So if you don't know what analysis services is, you can kind of think of it this way. There's a lot of different sources of data out there. Just in the cloud, just a couple. You have the SQL Server and the Azure SQL Database and Azure SQL Data Warehouse. Lots of other different sources, files, and same stuff on-prem or similar stuff on-prem. And you want to get your users access to that data. Now you could go and you just turn them loose on those databases if you want to. But let's actually look. I have a database. It's in a SQL Data Warehouse. And it's actually New York City taxi cab data. So of all the rides that happen in New York City in cabs, there's a record of it somewhere, and we actually found this data online. It's an open source data set out there. You can grab it. We grabbed it, we put it into an Azure Data Warehouse. It's a pretty big data set because it's every single ride in New York for a particular period of time.
Yeah, that's huge.
And here it is. And this is what it would look like in a data warehouse. We've kind of staged the data, we brought it in, we've done some ETL to it. But it's a list of tables. So if I want to go, and let me flip back to my other slide for a second here. I want to connect up some analytic tools or visualization tools like Power BI or like Excel or some other third-party tools. I could give my end users direct access to that data, which some users are good at. They'd have to know SQL in this case. But they'd also have to know how to query the data.
Yep.
Not just SQL. What table means what? What filters need to be applied? How do I get the number of trips? Is it a count of a trip table, or is it a sum of some measure, or some measure with a filter, or some field with a filter? You have to know some of the business logic about it, and you also have to know what each of these tables and columns mean. There's staging tables in here. There's a whole bunch of stuff in here.
Makes sense.
So what analysis services allows you to do is build this modeling layer in between your users and the data. So what it can provide then is kind of a view of the data to your business users, to your end users, without them having to know all that business logic, because you can bake it into that view. And you don't have to necessarily physically change the underlying data. So you store the data the best way it's meant to store, you make sure your ETLs are optimized, you make sure it's designed for long-term storage of the data. And you can present this view to your users that they can then go and query it. And by baking in some of that business logic, not only do you make it easier for them to query, but you also make it easier, or more likely that when people show up in the room in a meeting talking about the same numbers, they're actually talking about the same number. And you get to kind of that one version of the truth. So took this model here.
So before we move forward, I have several questions on this, because this is quite a departure from what I used to know about the multi-dimensional databases. So these views you just mentioned that you model in the middle, these are aggregated views.
So They don't necessarily have to be aggregated,
Okay.
but there's kind of two pieces of this. One is making your data kind of look good and presentable to your users, baking your business logic in there, baking your security in there. And there's another piece of accelerating that, making that performant and able to handle all the because now you made it easy for users. You're going to get a lot more users using the data, which is a good goal to have. You want to make sure it's performant and you're not taking down your databases in the back end. So there's kind of two ways you can use this. One is kind of just as a model, and all the queries kind of come in. When you're in Excel, you're in Power BI, they'll automatically generate queries against analysis services, which will then automatically generate queries against the Azure Data Warehouse or the SQL database, and it'll run those queries down there. That's one way. The other way is then also to use analysis services as a caching layer, where we will actually take the data and we will load it in memory. And all the queries that come in will hit that cache and will not have to go back to the data warehouse. So what this means is you'll get very, very fast performance. And you'll reduce the kind of the load on your backend in that case. So if I now have a couple thousand users using this data because it's so easy for them to get to and they're starting to rely on it, you don't have to kind of scale up your databases to handle that many users because they'll end up all hitting cache in this case.
Okay.
You get very fast results.
So when the data changes in the underlying database, will the changes be propagated into these views?
So if you're not doing a cache, then automatically
it's going to query that anyway.
Yeah, it's going to query that database. If you are using a cache, you will have to go and then kind of update that cache like you would other caches.
Okay.
And I'll show you some examples how you can do that programmatically. We'll play around with Azure functions in a little, and we'll update some of that data.
Okay, cool.
So here I started building that model on that data warehouse, the taxi cab data that I was talking about. And I start bringing in some of the tables. You notice the tables here, they're not necessarily named the same as that are in the data warehouse. So I can put friendly names on them. I can put friendly names on all the fields. I can add additional fields that make more sense. I can get rid of fields that users don't need to see.
Sure.
And I can also even add whole new tables that weren't even in the database if they just make the experience better. I can also do things like put descriptions on there, display folders, all kinds of stuff, just to make the data more presentable. But I can also then bake in some of the business logic. Notice here too that all the relationships are in here. So if I was doing this with SQL, I have to know how every table is related, on what fields. Some tables get related more than once to a different table. All this is supplied for you here. So when you go into a tool like Excel or Power BI, all you do is pick the fields you want, and I'll show you that in a moment, and you don't have to know about the relationships. It's all kind of taken care of for you in this model. But in addition to that, you can also go ahead and bake in some of that business logic. So we talked about, okay, what are the number of trips? So if I look at just the trip count measure that's in here, there's already a formula in here, and that formula just is trip count equals the count rows of the trip table. Very, very simple one. Here's a slightly less simple, but still simple one, just the revenue per trip. Well, it's a kind of a safe divide of revenue and the number of trips.
Right.
And these are just very simple ones, but even simple ones can provide a lot of value because you didn't have to know how to do this.
Yeah,
And
absolutely.
you can go much, much more complex in here and really take things that someone would have to have a lot of kind of business knowledge about to even get started. You can bake that in here and they can just come in and just select the field.
So these are relationships that you have defined.
These are calculations, these are measures.
Yeah.
If you're working in something like SQL, you could kind of pre-calculate certain things, but they're always pre-calculated.
Yep.
These are dynamically run every time someone runs a query.
Okay.
So it's almost like, equivalent would be almost like having a SQL snippet that you copy and paste into your SQL query. This is kind of automatically in there as it will show as a calculation that you can kind of drag in. And depending on what other fields you select, what other filters you select, that all gets fed into these calculations, and you'll get the result as of what you selected.
Yeah, makes sense.
Okay. Yeah, actually, the syntax of this, as well as the behavior, feels to me like an Excel formula.
Yeah, so this is a language called DAX, which actually we did create right back in 2008 for Excel.
Okay.
So it is actually part of Excel as well. There's a Power Pivot added in Excel that uses this language. And it was meant to appeal to Excel users and feel like you're writing Excel formulas.
Yeah, makes sense.
Now
I guess this is more familiar to the business people who's manipulating the Excel formulas to do some analysis.
Yeah, there are some differences, whereas Excel you're always dealing with kind of static data. You know your data, you have rows, you have columns, you can do this column plus this column. Here, you're working in kind of aggregates, you're almost working in kind of multidimensionally, where you want to take the sum of something, the sum of something else, multiply them together, and that's your calculation.
Right.
And you look at, okay, what filters are being applied, what row am I on after I do the summation. So there's all kinds of things where you're not dealing with static data, you're dealing with kind of data that's changing as you're pivoting around.
Okay.
So now we kind of built this model out, and there's other things you can do. One last thing I'll mention before I just show the demo of using it is while you're in here, you can actually also bake in your security model. So if, let's say I'm allowed to see certain cities, certain regions, and you're allowed to see different ones, we can both log into the exact same report
Okay.
with the exact same conditions applied to it, but you and I might see different data because we now have different security. And this is something you can apply to any data source that we support. We will then put that security layer on top of you. So flat file. Can't secure the data in a flat file. You can if you put this on top of there.
Very cool.
So let's actually look at it in action a little bit. So this is that exact same model. This is that exact same model that we've connected to in the Power BI desktop. Also in Excel. And what you see in here is you see kind of the friendly version of those fields that we created. I'll show it on the little bigger screen. So here are just the tables that we exposed in the model. It's not the tables that are in the data warehouse. It's some representation of them with the business logic applied so that the business users come in, they can understand and find what they need.
Sure.
So like I said, this is looking at all the data that's from that data warehouse for New York City taxi cab trips. So I asked earlier, what is the number of trips? So let me actually go, I put some extra little hints in here for me. Let's look at the number of trips. So what we actually did there, and this is cache data, so we actually put this data in that in-memory cache I was talking about. We actually ran a query right there, and we basically did a count all of the trips table. So if you remember that formula, we were counting the rows in there. We just counted 2-point-something billion rows. I can actually even change that so we can see it a little bit better. That was about just over 2 billion rows. We just scanned there.
It's pretty fast.
That's fast, yeah.
So it actually reached out to
that server.
Services.
Yeah, it's running in Azure right now.
Query.
And it ran that query, and it returned the results. So all in memory, it's column oriented.
Yeah.
It's very, very fast. I'll even leave that on there. So let's ask some more questions of it. The nice thing about data being fast, you can ask all kinds of questions. You can get the question. Yeah, you can ask questions that you find out weren't even necessary, but then you can ask other ones, and you can just keep trying and changing and doing things over and over again because it's very fast. You're not paying your time. You're not putting a lot of load on the service. You get to kind of work with that data, kind of in real time.
Yeah, I guess especially when you work with large data sets, sometimes you need to see the data a little before you can ask the correct questions.
Helps you narrow down where you want to have your targeted, where you want to be more targeted. So you can see from a high level and kind of drill through and get more and more detailed.
Yeah.
So let's get a little bit more detailed. Let's look at kind of where people are getting picked up in New York. So let's take let's look at where the longitude and latitude are where people are being picked up. And based on the metadata that's in this model, the Power BI desktop, as one of our client tools, is actually able to look at that metadata and say, okay, this is a location-based field, so we can put it on a map. And we take revenue and put it in here. So again, every time I'm clicking here, it's running queries. So it's just plotted all the trips on a map of New York. And the size of the bubble is how much was spent on those trips, so the cost of that trip or the revenue generated by that trip. And there's a lot of them. It's New York.
Yeah.
So let's maybe do a little bit more analysis here. Let's look at what are kind of the highest revenue per trip by the different pickup locations, the different zip codes. So let's I'll create another visual here. We'll call it revenue per trip, and we'll look at it by the different pickup locations. Look at the zip codes in this case. So you can see two really stand out there. Again, these are running queries every time I do this.
Yeah.
So any idea what the two big ones are?
I have no idea.
It's New York. Two things in New York that get a lot of pickups. Well, we can see, we can click on one. So what this is going to do now, it's going to actually run another query to filter down this one.
Very cool.
And we can see this is JFK Airport.
Ah.
You can see all the trips in JFK Airport. I'll flip it over to the other one. And that is LaGuardia Airport. We're actually loading faster than the big map at the moment. There we go. So it's really fast to explore the data. You can get answers to those questions, as in what is this, very quickly. And you can see, okay, these actually represent the latitude and longitude of where the customer was picked up. And I guess it's very busy at JFK, or people starting to extend onto the highway, it seems. So looking at this, it looks like you can make more money. If I'm a cab driver, I want to know where should I be picking my customers up at. It looks like I can kind of make more money here at JFK. At least per trip, I'm making more money at JFK than LaGuardia. But let's actually look at how long are these trips take you on average. So we can look at, make some room here. Let's look at the, let's go trip count again. Just kind of their average duration. And we change the orientation of this a little bit. And I'll do a slightly little advanced Power BI trick here where you can actually say how these visuals interact together. I can actually change this one to now filter this one instead of what we were doing before, was cross-highlighting. So I'll say edit interactions, and we'll say this is going to filter instead of cross-highlight. So now when I click on, this was JFK, you'll see only the values for JFK. And you can see the average. Most of the trips there are kind of in the 30 to 45 minute range. You get a few down, you still get a lot down here in the 15 to 30. But if you look at LaGuardia, you get a lot more in the 15 to 30 and very few in that 30 to 45 minute range. So you might be able to make more per trip by going to JFK, but you can probably do more trips by going to LaGuardia.
Right.
A lot shorter trips. So take that as you will if you're out there picking up customers. But this is a great way you can actually explore that data, and you can kind of see that speed, the value of that cache, and also the value of that model. We're able to find the fields we need and get to that answer.
Yeah. So you can do all those dynamic analysis based on the how many rows? 2.4 billion rows.
Yeah, a lot of rows.
Yes.
Yeah. And it just shows kind of the value you get out of that cache. It just really makes it so you can work with that data.
Yeah.
So here we are querying the cache.
Here we are querying the cache.
To the database.
Yeah. And part of how many users you can put on this thing is that these queries answer so fast is that you might have a lot of users trying to use it at once, but there's very little overlap because the queries are answering very, very quickly. So one other thing I did not show is that you can also then use this in Excel. And you have, I guess, look at the same trip count in here. I forgot to refresh since I came to the other room. Same speed. And there's lots of other tools out there, third-party tools. As you mentioned, analysis services has been around for a long time, so there are a lot of other tools out there that will do the same stuff. Yeah, that is a quick intro to AS. Now you mentioned how do we get this data in there?
Yeah.
So let's actually look. I have open up Management Studio again. I'm actually so if you are an existing analysis services user, you can actually use the same tools that you were using on premise and use them in the cloud. So this is Management Studio. I'm connected to. This is a different AS database I have. I'm actually collecting. We have a nice little sample on it's actually on the Power BI site where you can actually go put in some search terms, and it'll actually go and build a database for you, and it'll start looking at Twitter for those search terms and kind of fill that database with stuff. So I built a model on top of that, looking at people talking about Azure Analysis Services. So tweets come in very, very frequently, so I wanted to make sure this thing stays up to date. So what I did here, and I actually have this connected to it in another Power BI desktop file here. You can see the last time that I created a calculation here that shows the last time the cache was updated. And you can see it was right here. Now, what I did was I wanted to process this automatically, and like I said, you can use some of the same tools that you had on-premise, or the same tools you had on-premise, but you can also use some new tools. So I actually went and used an Azure function. Let that load.
So for those of you who may not be familiar with Azure Functions and what they do, it's essentially serverless computing. which means instead of having to host your own virtual machine or your own service out there, you just define actual function that gets run whenever you call it in the cloud.
And that's what I did here. And then we actually have, so we have a .NET object model that ships with analysis services.
Mm-hmm.
And I was able to actually take that, and I uploaded our assemblies into here, into the Azure function, and reference them. And I can actually now come in here, and using our object model, I can go and say, I created this function that will actually, it's based on a timer.
Yep.
So I could have gotten really fancy and said, okay, every time we see a new tweet about us, refresh the data. But I did a little less fancy. I just said, okay, I'm going to create a function that executes on a timer of every 5 minutes.
Mm-hmm.
And I referenced our object model in here, and analysis services tabular model. And I have a connection string, just like you would for any kind of database. You have a connection string to your analysis services model or database. And I connect to the server, I connect to the database, and I find the database that's in there. It's called AS Tweets. And in here, this is the simplest way of doing it. I request a refresh of type full. And if you do it on the entire model, it will refresh all the data in that model. But you can also get much more granular. The modeling tool I was showing you here before in Visual Studio is called SSDT, SQL Server Data Tools. Mm-hmm. For the analysis services part of SQL Server Data Tools, it uses the same object model that's right here. So you can get as granular as you can get in the authoring tools programmatically using this object model. So I could have gone down to individual tables. I could have refreshed individual tables. I could have actually partitioned the tables if I only want to load just incremental rows. This is a smaller database, so I can just go and refresh the whole thing. So I'm going to call the refresh type in here full. The nice thing about full is if you have users who are using your database actively, when we actually refresh it, we'll keep your database alive, the one that's already there, and we'll actually kind of refresh in the background. When it's done, we'll replace the other one with it, so it's kind of a no downtime way of actually refreshing. And I log out to the function when it's complete. So I can go ahead and run this. Should probably cleared the thing so you can see it easier. Once it completes, I think it completed. Should have cleared that out before. We can actually come back in. Oh, got a thing complete. Yep, got now. I can actually come back in here, and I can go ahead and refresh this, and you'll see the time changed.
Oh, cool.
So this I can run as an Azure function. I don't have to spin up any VMs. And I can run it on a timer, or I can be much more intricate and actually wait for events and trigger the refresh to happen. And this is just one of many ways to refresh the data inside that cache.
Yeah, I mean, that's relatively painless compared to what it might have taken in the past.
Yeah. And it incorporates with a lot of other things you might be doing in Azure already. If you're using analysis services as part of an application you built in Azure, you have tools and you have ways of managing those applications right now, and you can kind of incorporate this into those tools as well, other things you're using.
So how does the pricing work? How do we charge people for this service?
So it's basically priced on capacity. So we have a concept of QPUs, query processing units.
Okay.
And let's go ahead and create one.
All right.
And we'll see how that works. So same Azure portal. And I'll come in here, and we're under Intelligence and Analytics. And you can see the preview of Azure Analysis Services at the bottom of the list there. Mm-hmm. And we'll name the server standard Azure stuff. Research group. Pick your locations. And then you have the different pricing tiers. So the pricing tiers are kind of based on the capacity. There are two types of things. One is the cache size. So this says I can have 25 gigs of cache roughly. Mm-hmm. And the query processing units is kind of more analogous to how much throughput I can get, how much parallelization I can get, how many queries I can run at one time, and how complex those queries can be. So if you need more kind of throughput there, you would up your QPUs. If you need a larger cache size, you would kind of up your cache size. So I'll pick something standard. We also have this nice little developer getting started SKU where you can actually just try out really simply and just really kind of see how things work.
I see there you would have a shared infrastructure.
This one will be shared. Everything up here is it's dedicated. So you have that capacity. It's yours.
Yeah. makes sense.
Then you can also scale in between these if you decide you need more later.
Okay.
So I'll go ahead and I'll just create one here. It takes about 5 minutes. Now, if you think of what you had to do, I didn't actually hit create, did I? Now it takes about roughly 5 minutes. If you think about what you had to do with the SQL Server product, you were going out and you were buying, you had to provision hardware, you had to go get that hardware installed, deployed, and then you'd have to go install SQL. It's a much longer process.
Right.
And then if you have to upgrade it or you want to change the SKUs later, it's also a bigger process. Here, within 5 minutes, you got your server up and running.
Yeah, it pacifies it all for you.
Yeah, completely. Not worried about those updates. As we roll out new features, we'll roll them out to you. And I'll look at look at one that's already done. Once it's done, it'll just be loaded, and you have your connection string, your server name, and you can use it like you would any other analysis services server. Yeah.
No, that's very cool. So I'm definitely interested in and when you mentioned about the security model, that definitely sounds like it would be pretty powerful. Could you speak more to that?
Yeah, so we have, the way the security model works now, and we actually released some new stuff in the upcoming CTP that was announced a few weeks back. So the way it has always traditionally worked is you can create roles for your users, and you can assign your users to roles, but the roles can be something as simple as, like, I create a North American role, and all users in here can just see data for North America.
Okay.
Or they can be much more dynamic. I can have one role, and based on whoever the user is, I can write one of those DAX formulas there to decide what the filter will be. So I can look at, a lot of people will say, okay, you can see certain geographies, you can see certain products. So I might have mapping tables that say, okay, which products and which geographies you can see, and I can actually write a query that looks up in there, looks at the username and says, okay, what are they allowed to see, and dynamically creates the security filter. So basically, you can have an infinite number of combinations if you go that route.
Right.
And so that's our row level security, which means just it filters and changes the data.
Yep.
We recently announced for the CTP, hasn't quite made it into Azure IS yet, but it will soon, is the object level security. And that is or table level security. You can hide a specific table so users just don't even see the table is there.
So you might have like an HR organization and an IT organization, and you might have,
Yeah,
depending on what orgs they're in, they'll see different tables.
Yeah, there might be certain fields that are more privileged than others, and you just don't want the user to see them at all.
Yeah, makes sense.
Versus filtering out the data for them.
Yeah.
It would be just as if they didn't exist in this case.
Okay.
So you manage those roles using existing tools as well, or there's a separate surface for those?
So the roles, you can create them in STT if you want. You can also create them in Management Studio, and you can also create them programmatically.
Okay.
Through the object model I was showing before is called TOM, or Tabular Object Model.
Right. So what happens if I change the model? Do I need to reload the whole model?
Yeah, so if your experience in the past was with more multidimensional, you might remember there that most changes you made, you had to kind of reload the entire model or most of the model. With the tabular model, it's actually a lot more tolerant to changes. There's very few things that would actually require you to reload the entire model. In most cases, you can make a change without even seeing any kind of effect in terms of the data that's in the cache. Obviously, if you delete something and try to bring it back, you'll have to reload those pieces. But there are very few things now that will actually have to make you reload the entire model.
Cool.
And you can also, when you reload, changes are a little bit more isolated too. So if you change a table, sometimes if there was something that you'd have to reload, you'd just be that table in those cases.
Yeah, I think that's pretty good because usually when we do those kind of analysis, my model keeps evolving as well as I receive more data.
Yep.
Yeah.
And the great thing about this is that you have a central place for your model that your users can kind of come in and connect tools like Excel and Power BI to, and they can also then do their own analysis and evolve their own analysis on top of this, which is very powerful.
Awesome. So are there anything else you want to cover today?
I think we covered the main stuff. So Azure Analysis Services is in preview as of this past October.
Okay.
So please try it out and send us any feedback. We're always looking for what's the next feature we're going to add.
Okay. Do you have a Twitter handle you want to share with people?
Sure. It's my...
You do this, yes. Well, you have to say it.
I have to say it? All right, fine. I didn't plan out the name when I picked it. It's Josh Caplan, 1984.
1984, okay. All right. So this is great. I'm glad we got this update on the analysis services. Thank you very much. And
Thank you.
Like I mentioned, I hope you guys continue to support the Cloud Cover Show. And I guess, Chris, we'll see you next time. Thank you. Bye.
Thanks.